Drawing circular patterns with trigonometry. All right, let's do just a little bit of trig here. So this picture is the total amount of trig that you actually need from high school trig. If you have a circle centered at the origin, and you have an angle theta and some radius r, this point is at r cosine theta, r sine of theta. If you haven't had trig or don't know trig or don't remember trig, no problem. This is literally all the trig you need to know. Okay, so Python actually gives us sine and cosine, so we can compute this. This is important because you're going to need trig anytime that you're doing anything involving angles, involving rotating around circles, and so forth. Now, when we draw such points, we are rarely centered at 0, 0, especially on a window because 0, 0 is the top left corner. We're typically centered at cx, cy. So all you do is simply add cx, cy to r cosine theta, r sine theta. And that shifts the entire circle over that way. It's a translation, no problem. Now there's one more thing, and we have to remember in graphics, up is down. And this picture is not showing that. This picture is showing that. 0, 0 is in the left top corner. Cx, cy is down here. And to go up, we have to do right there. See that subtract sign there? That's the key. That's because up is down. So to go up on the screen, you actually have to subtract from y. So this picture captured how to go an angle of theta off of some point cx, cy, where theta is measured anti-clockwise, counterclockwise. So here's finally an example. You have to import math because math is going to be doing the sine and cosine. Okay, and we're going to make this picture right here. And so let's go ahead and actually copy this code and paste it, run it, and then discuss it. So we'll paste it here. By the way, you naturally should be playing along at home. So you've got to go make this run as well and make sure that, oh, draw Belgian flag is not defined because I had this draw function. Pardon me. I'll get rid of that code. And now we go ahead and run it. There it is. There's our clock. So let's look at what's going on. We have cx, cy, and r, which are the center of the window, which we're going to use as the center of the clock. And then a radius, which we'll do is the smaller of the width and height, and a third of that. So we can draw this clock at different locations with different radii. So let's actually prove we can do that by doing cx, cy, r equals, we'll do cx of 100, cy of, say, 200, well, let's do actually cx of 200, cy of 50, and r of 20. That's going to look awful, but there it is, okay? If we did r of, say, like 100, probably look better. Yeah. So in any case, we're specifying the center and the radius of this clock. So the first thing we do is we create the yellow portion, which is just cx minus r, naturally that's the left, cx plus r would be the right, and cx minus r is the top, cx plus r is the bottom. There it is. Now we multiply r times 0.85. As this says, is the time labels lie inside the clock face. So the radius from this point in the center to the center of that 3 has to be less than the radius all the way out to the edge. In fact, it's 85%. If I change this to say 50%, you'll see the numbers crawl in towards the center. I'll just leave it at 85. That feels like a more visually pleasing distance out. So now I need a loop to go around and place my hours down for hour in range of 12. Okay, so hour is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. When the hour is 0, we're actually going to draw 12 there. Otherwise, it's just the hour. So now I find the hour angle, which I'll revisit. And this is cx plus r cosine theta, cy minus r sine theta. This is exactly the code we said right here. So these two lines are unsurprising. Okay, but what about this hour angle? How am I computing it? Well, to begin with, naturally, if I want to go 12 hours in a circle, I'll divide by 12, and then I'll multiply by 2 pi. Not by 360, because we're dealing in radians, not degrees. There are 2 pi radians all the way around a circle. So I multiply by the entire angle around a circle times the fraction of the way around the circle that I intend to go. Fine. Now there's 2 more things I have to do here. Okay. The first thing is that we have, in trig, we are always going counterclockwise. So as angles increase, we're moving this way, away from the horizontal up in a counterclockwise direction. Of course, clocks go clockwise. That's why we call it clockwise. So we have to turn this around and go this way. That's what this negative sign does. we're subtracting the angle instead of adding the angle for each hour. That makes us go clockwise. The next thing is that trig angles start on the horizontal. So this would be 0 o'clock. But time naturally starts in the vertical. So what we have to do is we have to add this angle. This is 90 degrees going from here up to here. Okay? But we're in radians, so it's 1/4 of all the way around. All the way around is 2 pi. 1/4 of 2 pi is pi over 2. So we add pi over 2 to make it vertical, and then we subtract the angle to make it clockwise, and then we multiply by 2 pi to make it in radians, and we divide by 12 to make sure that we're getting the right fractional amount. We compute our x and y. Our label is simply the hour as long as it's not 0, otherwise 12, and then we create the text, and we are done.